It is 1 o'clock, so we'll go ahead and get started here. And it's my pleasure to introduce Philip Pixoto. He is a graduate student here with Dr. Rafael Bizanotto. He's in his first year of a PhD program, and he is going to present a seminar today on characterization of pregnancy-associated glycoproteins and progesterone as a predictor of twins and conceptus loss in high-risk pregnancy Holstein cows. And Philip is another Brazilian. I'm getting kind of surrounded by Brazilians now. He graduated from the Federal University of Goiás in 2015. He worked in private practice in Brazil for a couple of years, and then he went to the University of Illinois as a research assistant initially, and then as a master's student with Dr. Fabio Lima, who many of you know. And then he recently came here to UF. And so we're looking forward to your seminar, Philip. Thanks.
All right. Yeah, thanks for the introduction, Dr. Monsuel. Thank you, everyone, for attending for the seminar. Yeah, as Dr. Monsuel mentioned, I'm going to be talking about the characterization of pregnancy-associated glycoproteins and progesterone as a predictor of twins and conceptus loss in high-risk pregnancy Holstein cows. Can everybody see my slides? Everything okay?
Yep,
all right.
Looks good.
All right. So I would like to start my presentation talking about the pregnancy loss and the impact on the dairy industry. It is known that pregnancy loss compromises the reproductive performance in dairy operations. It has been estimated that each case of pregnancy loss costs an average of $600. And the prevalence of pregnancy loss ranges from 6 to 39% depending on the farm. Pregnancy loss is a multifaceted issue. It can be caused by infectious agents such as viruses, protozoa, bacteria, but those are well controlled with vaccination and preventive measures. It can also be caused by non-infectious factors, such as metabolic disorders, for example. So, in high-producing dairy cows, despite presenting infertilization of almost 80%, only about 28% of the high-producing dairy cows will reach term after time they die. And most of these pregnancy losses are occurring between the first trimester. In 2016, Dr. Milo Wiltbank published a work that he proposed like 4 pivotal periods for the pregnancy loss in the first trimester, and that's the causes that is involved in each of those pivotal periods. The first one was between days 1 and day 7, and that could occur because of fertilization in poor embryonic development, fertilization failure in poor embryonic development. Between days 8 and 27, problems regarding elongation, maternal recognition, maternal immune regulation failure. Between days 28 and 60, issues regarding placental development and embryo growth. And between days 60 and 90, problems regarding fetal and placental growth. So this window over here, the third one, between days 28 and day 60, is the window that most of the pregnancy diagnoses are performed. And it's going to be the window that the majority of our talk today are going to be mostly focused. So considering all this pregnancy loss scenario and its impact on the dairy industry, there is a critical need to diagnose pregnant cows and also the non-pregnant cows as soon as possible. But also, it's important to identify the cows that could be potentially presenting, that could be potentially experiencing pregnancy loss in the herd. So the most common methods for pregnancy diagnosis in cattle is rectal palpation and transrectal ultrasonography. So rectal palpation can be performed as early as 30 to 35 days post-breeding if conducted by a well-trained person. It does provide real-time and accurate results. although non-trained personnel can provide erroneous diagnosis, and also there's limited fetal viability information on this technique. About transrectal ultrasonography, it can be conducted as early as 28 to 30 days post-breeding. It does provide information regarding fetal viability. Fetal sexing can be performed beginning at days 55 of gestation, and it does provide real-time and accurate results. Although it does require a substantial amount of training, equipment investment, and maintenance. So if we consider limitation of both techniques, a demand for an easier, less costly, and more accurate test has emerged in the market, such as the use of biomarkers. So the most common biomarkers available in the market to diagnose pregnancy in cattle are the ones based on pregnancy-associated glycoproteins, the PEGs. So those biomarkers demand either a blood or a milk sample to diagnose those biomarkers in the sample. So here on the left we have, can you guys see my mouse? No? So here on the left we have the rapid visual test. As you can see, there's some reagents over here. You're going to mix that with the sample that you have. We're going to be following up with you're going to follow step-by-step instructions, and it's going to give you your results after a few minutes. And this other one over here, you need to collect the blood samples and send it to a lab, and then the lab is going to be contacting the person who sent it after a few, maybe a day or something, with the results. So the pregnancy-associated glycoproteins, they belong to the inactive aspartic proteases family. They are encoded for a multi-gene family, and they are produced by these cells over here known as binucleate giant cells, represented here in green. And these binucleate giant cells, they are in the trophectoderm over here, as on this red cell layer, and they start to migrate to the endometrium of the cow once the first apposition and attachments are occurring within the uterus. So around day 20 of gestation, these binuclear giant cells start to fuse with the endometrial cells. By day 25, these binuclear giant cells correspond to about 20% of the trophectoderm cells. And after these binuclear giant cells reach the endometrium, they start to secrete their products, and one of their products in the granules that they contain over here, these little dots over here, they're secreting the PEGs. And the PEGs have been identified in the maternal circulation as soon as day 20 post-breeding. So although PEGs have been studied throughout the years as placental markers and biomarkers for diagnosing pregnancy in cattle, their functions are still not well understood. And the circulatory concentrations of PEG will range concentrations from 0.38 to about 32 nanograms per ml between days 26 and day 32 of pregnancy. So this is another image from a rapid visual test. Here in this well, we only had the reagents, a negative control. Here's a positive control. Here on the dark wells, the darker light wells, we have the pregnant cows, and here we have the non-pregnant cows. So the manufacturer for this rapid visual test recommends that the earliest evaluation should be performed between 28 to 30 days post-breeding. This test does not provide fetal viability and also does not provide real-time results. You need to wait, even though if there's a few minutes, you need to wait for the results. But the most concerning part about this test is there are several studies providing data that these assays can provide a high incidence of false positive results. So this is a table that summarizes a few works that were performed using ELISAs to diagnose pregnancy in dairy cows using blood and milk as the source of pregnancy-associated glycoproteins to diagnose the pregnancy on those dairy cows. And on this table summary over here, the sensitivity ranges from 94 to 100%. However, the specificity ranges from 83 to 100%. So the specificity is the one that is being might be compromising the assay accuracy by providing the false positive results. And the factors that influence this assay accuracy are, first, parity. It has been reported that primiparous cows, they present greater circulations of PEGs compared to multiparous cows. Sire, it has been reported that cows bred from a specific sire, they produce embryos that secrete more PEGs compared to a different sire. Days postpartum, so it has been reported that PEGs are still circulating on cows, on the cow's maternal circulation, up to 90 days post-calving. In milk production, it has been reported that milk production can negatively affect the concentrations of PEGs on dairy cows. And our main plan for this afternoon, pregnancy loss. So the relationship of PEG and pregnancy loss have been studied throughout the years. And this is one example of the relationship of PEG and the pregnancy loss. So this work was published from Dr. Kai Poehler in 2016. And he enrolled dairy cows on his study. And he collected the blood sample from these dairy cows at day 30 post-AI. And he was using the PEG concentrations in the blood to predict pregnancy loss at day 60 post-AI. And he used an ELISA test using an antibody 45 and a commercial test, as in here in the line in black. So the commercial test did not provide a good sensitivity and specificity, but the AB45 did, with an area under the curve of 82.3, with a threshold of 1.4 nanograms per ml to predict pregnancy loss. In 2010, Thompson also evaluated the relationship of pregnant and non-pregnant cows using PEGs. So in Thompson's study, the non-pregnant cows at day 30, they presented the mean concentrations of PEG on those cows was greater than the threshold suggested by Poehler in 2016. Was way above than 1.4 nanograms per ml, even though the samples were from the same day and using a similar assay. So twins are also another factor that can play a role in the pregnancy loss. It has been reported that approximately 13% of twin conceptions results in pregnancy loss between 40 to 82 days post-AI. Spontaneous pregnancy reduction, when I mean pregnancy reduction, I mean like if the cow is holding a twin pregnancy, only one of the embryos are lost. This pregnancy reduction can happen in up to 28% of twin pregnancies between 28 to 40 days of gestation, and it is less common to occur after 60 days. Twin pregnancies at the same urine horn have 5 to 9 greater odds to lose their pregnancy when compared to bilateral ones. So this is a work that was published in 2016 by Dr. Irina Garcia, and she found that the concentrations of PEGs in twins was greater than the singletons from days 28 to 48 post-AI. However, the author didn't make any distinction between unilateral and bilateral twins, and also did not provide any information regarding pregnancy loss and pregnancy reduction in the analysis. So progesterone is another biomarker that have been studied throughout the years, and that was evaluated the accuracy to diagnose pregnancies using progesterone as a biomarker. So in 2004, Starbuck revealed a positive correlation at week 5 of gestation to cows that maintain their pregnancy at week 9 of gestation. And additionally, as on the previous work that I showed 2 slides ago, cows that were bearing twins presented greater concentration of progesterone when also compared to singletons from days 28 to 48 post-AI. So the PEG and the pregnancy loss relationship have been studied throughout the years by several authors by enrolling cows with an unknown pregnancy status or presenting a viable pregnancy, and then the pregnancy loss was collected with a blood sample later for multiple data collections. But perhaps in this model over here, the interval from enrollment to pregnancy loss might be too long. So our idea was, instead of enrolling cows with a viable pregnancy or an unknown pregnancy, we identify cows that were presenting a high-risk pregnancy on ultrasound, and by doing it, we could be shortening the interval from enrollment to pregnancy loss. With that approach, we could be getting more accuracy on assessment of the PEG and progesterone before the pregnancy loss. We also could evaluate the ultrasound changes in the pregnancy and also compare to the PEG and progesterone concentrations. And perhaps we could generate a threshold to predict pregnancy loss in twins. So our hypotheses were the plasmatic concentration of PEG and progesterone is reduced in cows carrying a high-risk pregnancy and can be used to predict pregnancy loss. Plasmatic concentrations of PEG and progesterone is elevated in twins and can be used to predict twin pregnancies. Our objective was to characterize temporal plasma concentrations of PEG and progesterone in Holstein dairy cows carrying high-risk pregnancy and twins, and to determine a threshold value of PEG and progesterone to predict twin pregnancies and pregnancy loss. So the study was conducted in this farm called Stone Ridge Dairy Farm. It was located in Mansfield, Illinois. It's about 30 minutes away from the University of Illinois. We were milking about 3,300 cows 3 times a day. The reproductive synchronization protocol of choice in the farm was a double wav sync, in which the breeding wav sync was a co-sync 72. And the pregnancy diagnosis was conducted by the farm personnel at day 37 post-AI via rectal palpation. The non-pregnant cows were resynchronized using off-sync, and the cows were first-time AI on average 66 plus minus 3 days in milk. So this is a representation of our criteria for enrolling cows that were considered as a high risk, and also cows that we consider controls. So here we have an image of a control cow, a cow that was considered a control because she was bearing a single-tone pregnancy in which the amniotic vesicle length was at least 15 millimeters and the heartbeat more than 6 beats per minute. In the high-risk group, it was subcategorized in three different subcategories. We had the slow heartbeat subgroup, in which the embryos were enrolled presenting a heartbeat less than 6 beats per minute. We also had the small embryo size, in which the amniotic vesicle of the embryo had less than 15 millimeters. And for last, the extraamniotic membrane, which consisted from cows that were diagnosed with a live embryo within the uterus, but there was also an empty extraamniotic membrane present, as you can see by the X denoted over here. And here in blue, we have our criteria for enrolling twins. So the twins were either bilateral or unilateral, in which the bilateral twins were viable twins present in different uterine horns, and the unilateral twins, viable twins present in the same uterine horn. And here in this black box is our criteria for pregnancy loss. The pregnancy loss was reported even either for a fetus that was absent within the uterine horn, or if the fetus was presenting no heartbeat at all. So this is our overall experimental design. So if a cow was identified in a farm bearing a high-risk pregnancy or bearing a twin pregnancy, these cows were immediately paired with a control cow. And this control cow was from the same pen, in the same day, and the same parity. Cows were enrolled in the study at day 37 post-AI. The ultrasound findings were recorded, and the blood sample was collected for PEG and progesterone. The procedures were repeated for day 44 and also for day 51 post-AI. So here we have the table summarizing the number of replicates that we had for each group and for each subgroup in our study. So we end up with 24 high-risk cows, 41 twins, and 65 controls. We had 11 slow heartbeat, 10 small embryos, and 3 extramembranes. We had 17 unilateral twins and 24 bilateral twins. So the PEG was analyzed using a sandwich ELISA, using a polyclonal antibody 63, similar to what was performed by Rees in 2018. And the progesterone was analyzed using a chemiluminescence assay that was previously validated for bovine, according to Bedford in 2018. And the intra-assay coefficient was 2.44 for progesterone and 10% for PEG. So our statistical analysis was conducted using JUMP, and the pregnancy loss was evaluated using a logistic regression, using a binary distribution and considering group, parity, time, and their interactions. Continuous variables such as PEG and progesterone plasmatic concentrations were analyzed via ANOVA, considering group, parity, and their time interactions. In pregnancy loss and twins prediction using PEG and progesterone from day 37 post-AI were also evaluated using a logistic regression and a receiving operating characteristics, ROC, to evaluate the prediction of those traces at day 51 post-AI. And pregnancy loss was also evaluated using the embryo sizes from day 37 post-AI, using a logistic regression in receiver operating characteristics, ROC, to evaluate the prediction of pregnancy loss at day 51 post-AI. So sample size. So our sample size was calculated based on a previous investigation conducted by Gabor in 2016. On that study, the pregnancy loss was reported in about 72.9% based on ultrasound abnormalities between 29 to 42 days post-AI. All the high-risk animals in the current study presented gestation abnormalities on ultrasound and were paired with normal appearing herd mates. So considering the matched pair design of our study, sample size was calculated to allow sufficient experimental units to detect a large Cohen's d effect of 0.80 for PEG and progesterone, with alpha of 0.05 and beta of 0.20 in a one-tail test. So according to the calculations, 12 experimental units per treatment were deemed necessary. So table 1 over here is a descriptive data of each group, the control, the high risk, and the twins, containing milk yield, days in milk at enrollment, number of services, and other traces. So milk yield, enrolled days in milk, number of services, stillbirth, and retained placenta presented no statistical difference among groups. 7 twin cows presented mastitis, and that was statistically different from the other 2 groups. So the overall percentage of pregnancy loss among days 37 to 44, days 44 to 51, and the total percentage at days 37 to 51 is presented here in table 2. So between days 37 to 44, 1 cow of the control group lost a pregnancy, 16 cows of the high-risk group lost a pregnancy, and 2 cows in the twin group lost a pregnancy. Between days 44 and 51, 5 more cows on the high-risk group lost a pregnancy, and 3 more cows in the twin group lost a pregnancy. The overall percentage of pregnancy loss was 1.5% on the controls, 87.5% on the high-risk groups, and 12.2% on the twins, on the cows bearing twins. So the overall percentage of pregnancy loss of the subgroups among days 37 to 44, 44 to 51, and the total percentage at days 37 to 51 is presented here on table 3. So similar to what was presented in the previous slide, but now we have the subgroups for both the high risk and for the twins as well. So here we have the small embryo subgroup, the slow heartbeat subgroup, the extramembrane subgroup, the bilateral twins, and the unilateral twins. So the overall percentage of pregnancy loss in the small embryos was 100%. On the slow heartbeat, 72%. On the extramembranes, 100%. On the bilateral twins, 8%. And the unilateral twins, 17%. Additionally, we reported a pregnancy reduction in twins of about 29.3% between days 37 to 51. So here in this slide, we have our first results for PEG and progesterone. So here we are comparing the concentration of both biomarkers at day 44 and at day 51 regarding parity. So at day 44 for PEGs, there was the non-pregnant cows and the pregnant cows presented no statistical difference on the PEG concentrations. But at day 51 post-AI, pregnant cows had statistically greater concentrations of PEG when compared to non-pregnant cows. For progesterone, pregnant cows had greater concentrations of progesterone both for day 44 and for day 51 post-AI. And here we have the concentrations of PEG and progesterone regarding parity. So the concentrations of PEG and progesterone were greater for primipares when compared to the multipares. And here we have the concentrations of PEG and progesterone for each group at days 37, 44, and 51. So there was a tendency effect on the PEG concentrations with a P equals to 0.05. There was a days post-AI effect, and the combination group and days post-AI showed no association, and there is no, It is noteworthy that control cows tended to present greater PEG concentrations when compared to the high-risk cows. For progesterone, twin cows presented greater concentrations of progesterone when compared to the other two counterparts. And the control cows presented greater concentrations of progesterone when compared to the high risk on day 44 and day 51 post-AI. And there was also an association of group. There was a tendency on the combination of group and day post-AI. So here I'm going to be presenting the concentrations of PEG for the subgroups on the high risk. So here we have the small embryos, the slow heartbeat, and the extramembranes. So here they are being compared to their respective controls. So the small embryos here, for example, they are being compared to the controls that they were paired with at enrollment. So at day 51 post-AI, small embryos presented statistically less concentrations of PEG when compared to their respective controls. This pattern was not observed for the slow heartbeats at any time point when compared to their controls. And the extraamniotic membranes presented a tendency for less concentrations of PEG at day 44 and at day 51 post-AI. In regards to progesterone, small embryos presented less concentrations of progesterone when compared to their respective controls. And the slow heartbeats presented less concentrations of progesterone at day 44 and at day 51 post-AI. In the extramembranes, only at day 51 post-AI, this difference was observed between the extramembranes and the respective controls. Now, in regards to the subgroups of twins, bilateral and unilateral twins, for PEGs and progesterone. Bilateral and unilateral twins presented no statistical difference in regards to the PEG concentrations at day 44, at day 37, 44, and day 51 post-AI. In regards to progesterone, bilateral twins and their respective controls had similar concentrations of progesterone, and the unilateral twins presented a statistical difference on the progesterone concentrations at day 44, and a tendency for less concentrations of progesterone at day 37 post-AI. Sorry, the controls presented less concentrations of progesterone, not the unilateral twins. And here we have the ROC in which we use the amniotic vesicle size at day 37 to predict pregnancy loss at day 51 post-AI. So the ROC did generate a threshold of 13 millimeters to predict pregnancy loss with an area under the curve of 0.88, presenting a sensitivity of 70.3%, specificity 93%, positive predictive value 73%, and the negative predictive value 92%. And here we have the concentrations of PEG and progesterone that were used from day 37 to predict pregnancy loss at day 51, and also to predict twins. So the ROC did not generate a threshold for PEG to predict pregnancy loss in twins with an area under the curve of 0.5 for both. And for progesterone, the ROC did found a threshold of 6.48 nanograms per ml to predict pregnancy loss with an area under the curve of 0.64, with a sensitivity of 58.3, specificity 77.7, positive predictive value 76.8, a negative predictive value of only 50%. For predicting twins, the progesterone threshold was 77.2 nanograms per ml, with an area under the curve of 0.70, presenting a sensitivity of 71.4, specificity 63.9, a positive predictive value of only 45.4, a negative predictive value 84.1. So in conclusion, the cows experiencing pregnancy loss had lower circulatory concentrations of PEG in progesterone, which is in agreement with previous studies. The use of plasmatic concentrations of PEG from day 37 post-AI collected from cows bearing high risk and twins presented no efficacy to predict pregnancy loss in twins at day 51 post-AI. The plasmatic progesterone collected from days 37 post-AI in fact predicted twins and pregnancy loss, however, only with moderate accuracy. So I'd like to take this opportunity to thank my previous advisor, Dr. Fabio Lima, and the other members of my committee in Illinois, Dr. Canisse and Dr. Garrett, the other co-authors on the work that we performed. A special thank you for the Stone Ridge Dairy Farm crew for helping on the data collection, and the Department of Veterinary Clinical Medicine in the University of Illinois for funding this study. And thank you guys for attending the presentation. I'll be taking any questions now. Seems like there's a question here in the chat. Brittany, can you further speculate on what is influencing the variability of PEG secretion in cows, a different parity and different sires? Brittany, one of the works that was conducted that reported that difference not that difference, the influence of milk production in the PEG secretion. In one of them, the author speculated that the fact that we are producing more milk, they also found that the cows were producing more milk for the multipares, and that could also be playing a factor on that concentrations of PEGs. So the author hypothesized that perhaps the PEGs, similar to what happens to progesterone, they are being more catabolized in the liver and also being secreted in the milk, and they are also decreasing more their concentrations in multiparous cows when compared to the primiparous cows as well. But also might be the factor that I think the author also mentioned something about, and I kind of agree with him right now, since the primipares are being, they were pregnant only once, they were more, they were producing more PEGs to establish their pregnancy in comparison to multiparous cows. But it's only hypothetical. There's nothing in regards to a study that conducted to prove these theories. Thank you for the question, by the way, Brittany.
Felipe, this is Ricardo.
Hey,
did you measure progesterone? I'm sorry if I missed that. Somebody called me here. But did you measure progesterone at all?
We did measure the progesterone. Like, we mean like with an assay?
Well, yeah. What time points did you measure the progesterone?
All right. So we measured the progesterone. Let me go back a few slides. We measured the progesterone. Maybe I speak too fast and I jumped that part. On our experimental design as well, we collected the blood sample for PEG and for progesterone on day 37, 44, and day 51 as well.
Okay. Did you do any analysis on how the progesterone could be used as a predictor of the pregnancy loss?
We did.
I'm sorry that I'm asking.
No, it's all right. It's all right. It's all right. I speak too fast too. So we did the ROC here, and it generated a threshold of 6.48 nanograms per ml, but it's only a moderate accuracy, and we can see here on the negative predictive value that only 50% of the cows were missed on this prediction. So how valuable it is? Not much. Like, that's why we only got like a moderate accuracy.
Interesting. We have some data in Jersey cows that progesterone at 31 days actually could help predict the likelihood that pregnancy would carry on to calving. And I believe that the cutoff point was 4 nanograms per ml or 5. Okay. Mm-hmm. And it was quite higher accuracy than what you're showing there. So it's
all right
to compare, because you use Holstein cows, correct?
Yes, we use Holstein cows as well. Yeah, and I mean we put on the analysis over here cows that were presenting high risk pregnancy, cows that were carrying twins, and as we saw, cows bearing twins, they have greater concentrations of progesterone, so that could also be influencing on the analysis as well.
So in your model to predict what was going to happen with the pregnancy, did you include the pregnancy-associated protein in the model together with progesterone or no?
Yes, Dr. Chabel, we did, but we didn't find any statistical difference. And if the association
did you test for collinearity between the progesterone and the pregnancy-associated protein?
I don't think we did.
That would suspend. Did you test for what was the relationship of progesterone and the pregnancy-associated protein in your data or no?
Yes, we did associate those two, like we did the combination of those, but we didn't find any statistical results using those for predicting of pregnancy loss and prediction of twins.
But were they correlated, the two of them?
What do you mean by correlated? Sorry, I don't follow. Might be my naivety in stats.
Did you try to determine if there was a linear correlation between the concentration of progesterone and the concentration of the PEGs?
We didn't do that. No, that we didn't do.
Because that would probably help explain the question that Brittany asked.
Yeah, okay. That's a good point. Yeah, that's a very good point. Yeah.
Thank you.
No, thank you. Thank you for the suggestion. Yeah.
Philip, good presentation, and your pace was very good. So Dr. Chapin was leaping, talking on the phone, and then
Hope not.
no, he was not. No, just kidding. So my question is more applied. Let's say. So yeah, you can do RLC, and the RLC gives you a cutoff and give you the sensitivity, specificity, and area under the curve. But it seems that that's what you went with. But of course, you can select other cutoffs that gives you a higher sensitivity or specificity.
Mm-hmm.
I wonder if you explored it and what would be useful, I guess, because at the end of the day, if you're doing this, I'm thinking about management, right? You're measuring and going through the trouble of measuring size of vesicles and
mm-hmm.
measuring pegs and progesterone and all of that. What would be the goal? You know, let's pick amniotic vesicle size. Do you want to detect, to be very good at detecting the cows that are going to lose the pregnancy or the cows that are not going to lose the pregnancy? You know, then you play with sensitivity and specificity. And what do you do? Right. So if I know which cows are going to abort or the cows that are not going to abort, I don't know if you had thought about that. Or I'm going to the farm on Tuesday, so I'm ready to start applying this. You just need to tell me how to use it if there is one that one cutoff that can be used.
Yeah, I usually just leave a few seconds after the question so I don't jump the gun on the answer, because sometimes the person has not finished the question. So yeah, I'm gonna go back to this slide over here. Yeah, I think that was very applicable. Like when we are doing this study, we are very cautious about measuring these amniotic vesicles in the farm because we are using the EasyScan and we are pretty much estimating the size. And Dr. Lima was very thorough with the details. He made me practice for about 3-4 months on measuring the amniotic vesicle to make sure that I was getting results similar to his to enroll the cows. And we are really confident that this measurement over here, it has a really good area under the curve by sensitivity and specificity. So the cows below 13 millimeters, they were losing the pregnancy. So I think it's applicable. I mean, we could test this a little more with more tests and more cows to check the efficacy. But I think it's something that it's worth to investigate at least.
Okay, so I measured, and this vesicle is 12 millimeters. Mm-hmm. What do I do? And the other one is 15. So how do I manage those two cows? That's sort of the angle that I'm.
You mean like something that can be done in order to, okay, this cow over here probably going to be losing the pregnancy, so let's give her a shot of prostaglandin. It's more than waiting for, it's more worth the shot than just waiting for her to carry on with the pregnancy, and if she loses later, okay, something on that line.
Something along those lines. Is this paper already written?
It's already published.
Published. Oh, okay.
Yeah. Yeah, it's already published.
Yeah, but I mean, next time you present this, maybe something to think about, right? So applicability. You know, if you're gonna go through the trouble of measuring these vesicles, what's the applicability of this information?
Yeah.
How can I manage these cows differently? Otherwise, you know, I'm not gonna go through the trouble of measuring the vesicle, but it takes time. Like you said, it took a lot of time to practice to get this right.
Yeah. Yeah, sorry, go ahead. Sorry.
No, I'm done.
So yeah, I think on the overall goal, like we can reach a certain level of accuracy that we can just say, hey, there's plenty of data showing that these cows with below 13 millimeters, they're going to be losing the pregnancy. So why wait? So why don't we resynchronize this cow over here today instead of waiting for this cow to lose the pregnancy? Yeah. So Dr. Monsuel sent a question, right? From Anna. Why your experimental design, you choose to measure PEGs within 40 days? If the PEGs peak 10 days before? Anna, thank you very much for that question. It's a very interesting question. One of the reviewers of our paper asked that question. So one of the factors for evaluating the PEGs at day 37 and not at days 30, for example, first, the farm personnel was already conducting the pregnancy diagnosis on the farm by rectal palpation at day 37. And this farm was a farm that was very hard for us to have access for all the years. And we discussed with them about the possibility of checking those cows on day 30. And they did not allow us. They said, you guys can perform the study, but at day 37, follow me the pace of the crew. That was it. And then after we had that information, we thought, oh, okay, maybe the cows that are presenting the high-risk pregnancies, the decrease on the PEG concentrations might be more sharpened than compared to the cows bearing the singletons pregnancy. Of course, it was not what we saw here, but that was our hypothesis. But thank you for the question, Anna. That is a very good question. You're welcome. All right.
Have any other questions for Philip?
I have one, so I also might have missed it, but did you follow the cows further to see, like, if there was the actual losses of the pregnancy?
Oh, hi, Catalina. Yes, we did follow the cows. I mean, we're not performing ultrasounds, but we did evaluate those on Dairy Comp, which was the software of use on the dairy farm, to evaluate which the cows remain pregnant, which cows did not remain pregnant. Like, for example, the twin cows, out of the 24 bilateral twins, 13 delivered calves, and out of the 17 unilateral twins, 5 delivered calves. So 54% of the bilateral twins and 30% of the unilateral twins delivered calves, for example. Twin calves, for example.
Okay, thank you.
All right.
All right. I think unless we have any other questions, we'll go ahead and finish there. Thank you very much for your presentation. It was really well done and interesting to hear what the work that you were doing up there.
Yeah. Thank you, Dr. Mosel. Thank you, everyone, for the questions. I'm looking forward to speak again.
Okay.
All right. Thank you.
Thanks.
Thank you.
Bye, everyone.